this lesson. I'm teacher Agnes, and today we are going to be discussing about decimals. Now, different numbers can be categorized into different categories. In the previous lessons, we have learned about numbers being categorized into even numbers, prime numbers, odd numbers, factors, multiples, and so on. One or the other way of categorizing numbers is into decimals. So which type of numbers do we refer to as decimals? So a decimal is a number that has two parts, okay? So a decimal has two parts. One of the parts represents a whole number, okay? One of the parts represents a whole number, and the other part represents a fraction. Okay, a fraction. Then the two parts, that is the whole number part and the fractional part, are separated by a decimal point. By a decimal point. So what is an example of a decimal? If you have a number like 4.65, like you can see, we have a number on this side of the decimal point. This is the decimal point. Then we have these two numbers. So this is a whole number, okay? And then this is a fractional part of the decimal. This means that the 0.65 is not a whole number. It's a fraction of a number. So this is what we are referring to as a decimal point. A decimal point. Okay, so other examples of decimal numbers should be like 5.2, 0.007. So you can have as many as you can, as long as it's a decimal point separating the whole number and the fractional part. Now the numbers that come after the decimal point are called decimal places. Decimal places. Okay, so for instance, this fraction here, this decimal here, 5.2, has got how many decimal places? Just one, because the number that comes after the decimal point is just one. Well, this one has got how many decimal places? 3, because after the decimal point we have 1, 2, 3. So the decimal places are the numbers or the digits in a decimal number that come after the decimal point. Now, you can always convert between decimals and fractions, then fractions and decimals. So you're going to look at how can you change a decimal into a fraction, how can you change a fraction into a decimal. So we are going to begin by converting fractions into decimals. So we're going to do this using an example. So if you have a fraction like 3 divided by 4, this can be written as 3 divided by 4. So what we are going to do, we are going to divide using the long division method, okay? Using the long division method. So we want to divide 3 by 4. So we are going to use long division to convert this fraction into a decimal. So this will be equal to, we divide, so we have 4 and then 3. So this is 3 divided by 4. Now, since 4 is greater than 3, we will have to add a decimal point and a 0 here so that we form a number that is greater than 4. And we do the same at the top here, 0 point. So 4 divided by, so we treat this like 30. So 4 goes into 30 how many times? It goes into 30 7 times because of, 28. 4 times 7 is 28. So we write this as 2.8 there. Then now we subtract, 0 divided by 0 minus 8. You can't do that, so we borrow 1 here to remain with 2. Then this is 10. So 10 minus 8 will be equal to 2.2 minus 2 is 0. So now we just have 0.2. Now since 2 is less than 4, we will have to add a 0 again. Then now you ask yourself, how many times does 4 go into 20? 5 times. So we write this as 5, and 4 times 5 is 20. So 20 minus 20 will give you a 0. So we cannot, continue because we have gotten the 0. So this means that if you divide 3 by 4, you will get 0.75. So 3 over 4 as a decimal will be equal to 0.75. Now let's try another example. Now in this example, we are going to convert 20 over 7 into a decimal. So we are still going to follow the same formula. So this is 20 divided by 7. So if we do long division, then this is going to be equal to 20 divided by 7. So 7 goes into 20 how many times? 2 times, because of 14. 2 times 7 is 14. Then we subtract. 20 minus 14 is equal to 6. Now you realize that at this point, 6 is less than 7. So what do? We add a decimal point and a 0. Then we add a decimal point here also. So 7 goes into 60 how many times? 7 goes into 60 8 times, because of 56. So we write that as 5.6 so that we can balance the decimal points. Then now we subtract. 60 minus 56 will be equal to 4. So now we have 0.4 here. So we add a 0 because 4 is less than 7. Now 7 goes into 40 how many times? 5 times, because of 35. Okay, so we subtract here, we get 40 minus 35 is 5. Remember our decimal point. Now again, 5 is less than 7, so we add a 0. But you see now this will go on and on and on, and will continue building into our decimal number. So in a case where you have a decimal that is not coming to an end, you decide where you want to stop at, or you follow the instructions given by the teacher, but we are going to look at that later on. So at this point, we can decide to equate our fraction to this decimal point, because even if we continue, we will go on and on without getting to the end. So 20 over 7 can be said to be equal to 2.85 as a decimal. Okay? Yes. So let us now look at how do you convert decimals into fractions. Now, converting decimals into fractions is actually very easy. So we're going to do 2 examples and see how this happens. So if you have a decimal like 0.45, how do you express this as a fraction? So what you do is that you count the number of the decimal places. Do you remember what are decimal places? These are the numbers that come after the decimal point, that is to the right of the decimal point. So we have 1, 2. So we have 2 decimal places. So this number can be written as 45 divided by a number that begins with 1 and has 2 zeros, because the decimal places are 2. So this will be 45 divided by 100. Then now at this point, you can simplify. For instance, 45 and 100 are both divisible by 5. So 45 divided by 5 will be equal to 9. 100 divided by 5 will be equal to 20. Is there a common number that can divide both 9 and 20? No. So this is the farthest that you can go. So 0.45 is equal to 9 over 20. Another example would be 3.25. Okay? 3.25. Now notice that here we have a whole number. Remember we said that in a decimal we have 2 parts, the fractional part and then the whole number part. So in this case, this number can be broken down into 3 as a whole number plus 0.25. So what we need to express as a fraction? The 0.25, because that is what represents the fractional part. So this will be equal to 3 plus, again, what do we do? Count the number of the decimal places. How many do we have? 1, 2. So we divide by a number that begins with 1 and has 2 zeros. Which number is that? 100. So this will be equal to 25 over 100. Now this will be equal to 3 plus 25 and 100. Are they divisible? Yes. 25 divided by 25 is 1. 100 divided by 25 is 4. So now we have 3 plus a quarter, which is now equal to 3 and 1 over 4. And that is a fraction that represents 3.25. So now I'm going to give you 2 questions that you are going to attempt on your own, and then you are going to proceed and find out what are recurring decimals. So now to practice what we have just learned, I will need you to attempt these 2 questions. Convert 3 over 5 to a decimal, then convert 6.15 to a fraction. Now once you get this right, come right back and check out what are recurring decimals. Let's look at an example that has more than 2 decimal places, like 21.005. Okay, so 21.005, if we need to convert this into a fraction, what do we do? So remember, 21 represents the whole number, so this can be broken down into 21 plus 0.005. This will be equal to 21 plus, counting the number of decimal places, we have 1, 2, 3. So this will be 5 over a number that begins with 1 and has 3 zeros, that is 1,000. So this will be equal to 21 plus, these 2 can be simplified. 5 divided by 5 is 1. 1,000 divided by 5 is 200. So when you add these, you get 21 and 1 over 200. Alright, now so what are recurring decimals? So a recurring decimal is a special type of a decimal, and the special thing about it is that it does not end, but we have some numbers, either one number or 2 numbers, that repeat themselves endlessly. Okay, what you're going to do, we're going to convert one fraction into a decimal and then see how the decimal comes out. So we're going to do, or rather we're going to convert 5 over 6 into a decimal. So remember what we said, you write this as if you're dividing normally. 5 divided by 6. Then you do the long division for 5 divided by 6. So this is going to be, okay, we are dividing 5 by 6. So 5 divided by 6. So if you try to divide, 5 is less than 6. So we need to add a decimal point and a 0, then 0 point here. So 6 goes into 50 how many times? It goes into 58 times, because of what is 8 times 6? 48. So this will be written as 4.8. Then now 50 minus 48 is 2. So we have 0.2 there. And since 2 is less than 6, we add a 0. So 6 divided by 20 will be 3 because of 18. Again, we subtract. 20 minus 18 is 2. So we add a 0 again. So 6 divided by, so 6 goes into 20 how many times? 3 times. So we have 3 there because of 18. If you subtract, you get 2. So by now you have realized that it's a pattern that is forming. 2018, 2018. So we are just going to get another 3 here because of 18, and so on and so on. So this decimal will never come to an end, but you realize there is only one number that is getting repeated, which is 3. So 0.83333 and so on is an example of a recurring decimal. So how do we write this? Because now we can't write all the 3's to even fit in our book. So this decimal would be written as 0.83, and then we put a dot above 3. What does this show? This shows that the 3 is the one that repeats itself over and over again. Okay? So this is how you write a recurring decimal. Now tell me which numbers are recurring here. So let's say I have 0.45 and then the dot is on 5 alone. This means that it's only the 5 that is going to repeat itself. So this is the same as 0.455 and so on. The 5 can go on and on. Now what if you have 0.45 but then the dot is on 4 and it is also on 5? What does this mean? That both 4 and 5 are repeating themselves. So this will be 0.45, 45, 45 and so on. Okay? So this dot tells you which numbers are being repeated. Now if you have 0.312 and then we have the dot on 3 and 2. Now this means that the whole number beginning from 3 all the way to 2 is repeating itself. So this now would be equal to 0.312, 312 and so on. So you realize that a recurring decimal is now different from a normal decimal. So the rules that we are using to convert a normal decimal into a fraction are going to be different when it comes to converting a recurring decimal into a fraction. So we are going to work out some questions and see how we can convert some of these recurring decimals into fractions. So let us convert between decimals and fractions. Recurring decimals and fractions. So you're going to begin with 0.5 recurring. So this dot means that it is a 5 that is repeating itself, so many times. So we're going to use algebra here to help us convert. So let letter A be equivalent to this decimal. So this decimal can be written as 0.555 and so on. Now, the intention here is to ensure that we are able to subtract, multiples of this decimal and end up with a number that does not have decimal points. Remember, we want to convert into a fraction. So we want to create multiples of this number, of this decimal, okay? And these multiples will be created by multiplying it by numbers like 10, 100, 1000, and so on. So the first multiple that you're going to create, we're going to multiply A by 10. So 10A, so when we multiply by 10 on this side, we must multiply by 10 on the other side. So 0.555 multiplied by 10, the decimal point will move forward once. So this will be 5.55. We can add another 5 to match these 3, because remember we can have as many 5s or as less 5s as we want. Now if you look at the number after the decimal point, this is 5 and then this one is 5. So this tells us that if we subtract the two numbers, we will not have a decimal, because the 3 numbers and these 3 numbers are the same. And when you subtract two numbers that are equal, you get a 0. And this was our intention, to get to a point where if you subtract any two multiples, we do not get a fractional part of the decimal. So we are going to subtract 10A minus A, which is equal to 5.555 minus 0.555. So as we do more examples, this will become more clearer for you. So 0.555 minus 0.555 gives you a 0, because like you can see, these numbers are the same. And now we have 5 minus 0, which is 5. And then on this side, we have 10a minus a, which is equal to 9a. Now, remember a is equal to our recurring decimal. And we want to determine the value of a, because a is our recurring decimal. So how do we get a from here? We divide this side by 9, we divide this side by 9. So a will be equal to 5 over 9. So our decimal, which was a and equal to 0.555, is equal to 5 over 9, because a is still equal to 5 over 9. Let's look at another example. In this second example, we have 0.73, and 3 is the one that is recurring. So let us give it a letter. Let's still use a. So let a be equal to 0.7. 3 is recurring. Okay? Now again, we create multiples of a. So we multiply by 10. 10a is equal to, if you multiply this by 10, the decimal point moves forward by 1 step, so 7.333. So now, if you check the numbers after the decimal point above here, we are beginning with 7, and here by 3. So if you subtract the 2, you still end up getting a decimal, okay? Because 7 minus 3 will give you 4. So you proceed by creating another multiple. So 100 now times a, then 100 times a means that you move the decimal point forward 2 steps. So this will be 73.333, and so on. Now, if you compare these 100a, 73.3, with the a, 0.7, the number after the decimal point is still different. But if you compare 10a with 100a, the number after the decimal point is the same. It is 3 here and it is 3 here. This means that we can subtract the 2 and come up with a number that does not have a digit after the decimal point. So that is what we are going to do. 100a minus 10a will be equal to 73.333 minus 7.333. So this minus this. So if we subtract here, 3 minus 3 is 0, 3 minus 3 is also 0. 73 minus 7 will give us what? This will give us 66. Then 100a minus 10a is 90a, is equal to 66. Remember, our intention is to obtain a value representing a, because a is the one that is equal to our recurring decimal. So at this point, we divide by 90 on both sides to obtain a. Okay? So our a will be equal to 66 over 90. Can we simplify this? Yes. Both of these numbers are divisible by 6. So 66 divided by 6 will be equal to 11 over 90 divided by 6 will be equal to 15. So our recurring decimal, 0.73 recurring, is equal to 11 over 15. Let us look at one more last example. Now for this example, we have 0.27. Now the dots are on 2 and 7, meaning that both numbers are being repeated. So let a be equal to 0.2727. So this continues on and on. So again, we get the multiples of a. So 10a will be equal to, we move the decimal point forward once. So that will be 2.727. Now, the number after the decimal point, the numbers after the decimal point are not the same. So we keep going. So 100a will be equal to, we move the decimal point forward to have 27.333. 0.27. Now this is 2, which is similar to what we have here. So now we can work with A and 100A. But since we have 4 decimal places here, we can add another 27 here so that they balance. Remember, we can have as many numbers after the decimal point as we want because it is a recurring decimal. So now we have 100A minus A, which is equal to 27.2727 minus A is 0.2727. So on this side, we are sure that if we subtract, we get a 0 because the numbers are literally the same. Then now 27 minus 0 is 27. Then 100 minus 1 is 99. So we have 99A, which is equal to 27. We are interested in getting the value of A. So we need to divide this side by 99, this side by 99. So the 99s will cancel each other. Then we have 1, or rather A, being equal to 27 over 99. Are these two numbers divisible by any number? Yeah, they are both divisible by 9. So 27 divided by 9 is 3. 99 divided by 9 is 11. So A, which is our recurring decimal, will be equal to 3 over 11. So let us look at one final example and then I'll give you some questions to attempt. Now, in this final example, you notice that the recurring, the dot that shows which numbers are recurring is on 5 and then on 4. What did we say this means? This means that the numbers beginning from 5 all the way to 4 are recurring. So let A be equal to, so this will be 0.504504. Okay? So we go on and get the multiples. 10A will be equal to 5.04504. Then, since this is 0 and this is 5, and they are not the same, so we go ahead and get 100A, which will be equal to, we move the decimal point forward one step again, so this becomes 50.4504. So now this is 4, this is 0, and this is 5. So we still don't have two multiples that have the same numbers after the decimal point. So we move on. 1000A, which will be equal to, we move the decimal point forward, this becomes 504.504. So this is 5 now, which is equal to this 5. So now we can work with A and 1000A. So when subtracting, we'll have 1000A minus A being equal to 504.504504. Remember, we can add as many numbers as we want. Then we subtract this value 0.504504. So we are sure that after the decimal point we get a 0 because these numbers are the same. So we have 504 minus 0, which is 504. Then 1000 minus A will be equal to 999A, and this is equal to 504. So how do we get A from here? We divide both sides by 999, right? We divide by 999. So our A will be equal to 504 over 999. Okay? So having learned how to express recurring decimals into fractions, I'll give you a few questions that you're going to attempt and test whether you have understood how to do it. Now, to test your skills on this, you will convert the following recurring decimals into fractions: 0.6, recurring, 0.43, and both are recurring, then 0.103. I'll let you figure out which of these numbers are recurring. So thank you for being in this lesson, and see you in the next lesson.